Hello and welcome to our series on data for the T level in digital production design and development. In this series, we'll be exploring the fundamental concepts of data, information, and knowledge, the building blocks of digital systems and decision-making processes. As future digital professionals, understanding these concepts is crucial. Whether you're designing databases, developing applications, or analysing data for business insights, a solid grasp of these principles will be invaluable in your career. We'll start by breaking down the differences between data, information, and knowledge. Then we'll explore how these elements interact and transform, enabling businesses to make informed decisions and create value. Throughout this series, we'll use practical examples and scenarios to help you apply these concepts in real-world situations. We'll also have quick questions and more in-depth exercises to test your understanding along the way. Are you ready? Let's begin with our first video on the nature of data itself. We're constantly surrounded by data, but what exactly is it? Let's break it down. Data is the foundation of all information systems. It's best described as unprocessed raw facts and figures. The key thing to remember about data is that on its own, it has no meaning. It's just a collection of numbers, letters, symbols, or even sounds and images. Let's look at an example. What does it mean to you? Probably nothing, right? That's because it's just data, a random assortment of characters without any context or structure. But where does all this raw data come from? Data is generated from countless sources. Every time you use a digital device or service, you're likely creating data. When you make a purchase with a credit card, data about the transaction is created. When you browse websites, data about your online behaviour is collected. Smart devices in homes and cities constantly generate data about energy usage, traffic patterns, and more. In business, data might come from sales transactions, customer feedback forms, or sensors on manufacturing equipment. Even natural phenomena like weather patterns generate vast amounts of data through various monitoring systems. Social media platforms are another massive source of data, capturing everything from user preferences to social interactions. All of this raw data has the potential to be transformed into valuable information. Data can be qualitative or quantitative. Qualitative data describes qualities or characteristics, while quantitative data deals with numbers and measurements. For instance, the colour of a car would be qualitative data, while its weight in kilograms would be quantitative. It's important to note that data can come in various forms. It's not just numbers and letters. Data can also be graphics, like images or diagrams. It can be sounds, like audio recordings. Remember, the key characteristics of data are: it has no inherent meaning on its own. It can be qualitative or quantitative. It's raw and unprocessed. It can consist of various types: letters, numbers, symbols, graphics, or sounds. Now let's test your understanding with a question. Imagine you're explaining the concept of data to a friend who isn't studying programming. How would you describe data using an everyday example? Think about objects or information you encounter in your daily life that could be considered raw data. Take a moment to consider your answer. Pause the video if you need more time to think or jot down your ideas. I hope you came up with some interesting examples. You might have thought about things like the numbers on a car's license plate, the individual pixels that make up a digital photograph before it's processed into an image, the raw audio waves of your voice before they're processed by your phone during a call, the letters and numbers in your postcode before they're associated with a specific location. These are all excellent examples of raw data. They're unprocessed facts or figures that, on their own, don't have any particular meaning. Remember, the key is that data is the basic building block of information, but it needs context and structure to become meaningful. Now that we understand what data is, Let's explore how it transforms into something useful: information. Information is created when data is processed. There's a formula we use to describe this transformation. Information equals data plus structure plus context plus meaning. Let's break this down. Structure refers to how the data is presented. For example, a date might be structured as DDMMYYYY. The structure for a UK postcode would be something like AA9A9AA, where A represents a letter and 9 represents a number. Context is the environment or background that helps us make sense of the data. For instance, the numbers 15, 24, 7 mean nothing on their own. But in the context of a 24-hour clock, we understand them as times of day. Meaning is what we get when we combine the correct structure and context. It's what allows us to interpret and use the information. Here's an example to tie it all together. Imagine you see the data, 15, cabbages, rabbits. On its own, it doesn't mean much, but let's add structure and context. 15 cabbage plants were planted, but the rabbits ate all of them. Now we have information. The data has been structured into a sentence and given the context of gardening and pest control. The key differences between data and information are: information has context, while data doesn't. Information is structured or coded in a specific way. Data must be processed to become information. In business and digital systems, this transformation from data to information is crucial. Companies collect vast amounts of data, but it's only valuable when it becomes information that can guide decision-making. For instance, a retail company might collect data on product sales. This raw data, just a list of numbers, isn't very useful on its own. But when it's processed into a sales report showing trends over time, popular products, and slow-moving stock, it becomes valuable information that can inform inventory decisions and marketing strategies. Understanding this relationship between data and information is key in digital production and design. As digital professionals, you'll often be involved in creating systems that collect data and transform it into useful information for users or decision makers. Now that we understand data and information, let's take a step further and explore the concept of knowledge. Knowledge can be defined as the ability to understand information and to form judgments, opinions, predictions, and decisions based on that understanding. It's the next level in our data hierarchy, where information becomes actionable and meaningful in a broader context. Let's break this down. Knowledge is more than just having access to information. It involves comprehending the relationships between different pieces of information, recognizing patterns, and grasping the implications of the information. With knowledge, we can evaluate information critically. We can assess its reliability, relevance, and importance in different contexts. Knowledge allows us to use past and current information to make informed guesses about future outcomes. This is crucial in areas like business strategy, scientific research, and technological development. Perhaps most importantly, knowledge empowers us to make informed decisions. We can weigh options, consider consequences, and choose the best course of action based on our understanding. For example, let's revisit our retail company. They've collected data on sales and processed it into information showing sales trends. Knowledge comes into play when a manager uses this information, combined with their understanding of market conditions, customer behaviour, and business goals, to make strategic decisions about inventory, pricing, or marketing campaigns. In the context of business application development, knowledge is what allows professionals to interpret user data, understand system performance metrics, and make informed decisions about design improvements or feature developments. It's important to note that while data and information can be easily stored and transferred digitally, knowledge is more complex. It often resides in people's minds and is built through experience and learning. However, Knowledge management systems aim to capture and share knowledge within organizations, turning individual knowledge into a collective resource. Understanding the progression from data to information to knowledge is crucial in digital fields. It helps us design better systems for data collection and processing, create more meaningful information displays, and ultimately support better decision-making processes. In our next section, we'll introduce a model that ties all these concepts together, the DIKW pyramid. This will give us a complete picture of how data, information, and knowledge relate to each other, and even hint at the next level beyond knowledge. Now that we've explored data, information, and knowledge individually, let's look at a model that ties all these concepts together, the DKW pyramid. DKW stands for Data, Information, Knowledge, and Wisdom. The DIKW pyramid is a hierarchical model that represents the relationships between these four elements. Let's visualize it. At the base of the pyramid, we have data, the raw facts and figures we started with. Above that, we have information, data that has been given context and meaning. The next level up is knowledge, the ability to understand and use information. And at the top, we have wisdom, the ability to make sound judgments and decisions based on knowledge and experience. Each level of the pyramid builds on the one below it, adding value and complexity as we move up. Let's break down what each level contributes. Data answers the question, what? It's the basic observations and measurements. Information answers who, what, where, and when. It provides context and meaning to the data. Knowledge answers how. It applies information to understand patterns and relationships. Wisdom answers why. It incorporates experience and insight to make judgments and decisions. As we move up the pyramid, we're adding value at each step. We're taking raw data and transforming it into something increasingly useful and actionable. For example, let's apply this to a digital scenario. Data, the number of clicks on a website button. For example, 1,000 clicks. Information, 1,000 clicks on the Buy Now button on the product page over the last week. Knowledge, understanding that this represents a 20% increase from the previous week and correlates with a new marketing campaign. Wisdom, deciding to expand the marketing campaign and adjust the website design to capitalize on this trend, based on this knowledge and past experiences with similar patterns. In digital development, you'll often be working at all levels of this pyramid. You might be designing systems to collect and store data, creating interfaces to present information effectively, developing algorithms to generate knowledge from patterns in the data, and ultimately creating tools that help users make wise decisions. Understanding the DIKW pyramid can help you see the bigger picture in your digital projects. It reminds us that while collecting data is important, the real value comes from moving up the pyramid, turning that data into information, knowledge, and ultimately wisdom that can drive better decisions and outcomes. Imagine you're working for a growing e-commerce startup called Tech Trends. They sell the latest gadgets and tech accessories online. The company has been collecting data on customer purchases, website traffic, and user behavior for the past year, but they haven't done much with this information. The CEO approaches your team with a challenge. We have all this data, but we're not sure how to use it to improve our business. Can you help us turn this raw data into actionable insights? Your task is to apply the concepts of data, information, knowledge, and wisdom to help Tech Trends make better business decisions. Consider, what kind of raw data might Tech Trends have? How could this data be structured and contextualized to become useful information? What knowledge could be derived from this information? How might this knowledge be applied to make wise business decisions? In the next part, we'll explore some potential answers to these questions. Now let's break down how we can apply the DIKW pyramid to help tech trends make better use of their data. Starting with raw data, tech trends likely has a wealth of numbers and codes that, on their own, don't mean much. This could include sales figures, timestamps of when users visit the site, product codes, user IDs, and click counts on various website elements. Remember, this is just data, numbers and text without context or meaning. Moving up to information, we start giving this data structure and context. Sales figures could be organized into daily, weekly, or monthly reports, showing trends over time. User engagement could be calculated into metrics like average time, on-site, or bounce rate. Product codes could be translated into popularity rankings. User IDs could be analyzed to create customer demographic breakdowns. Now we're starting to see some meaning emerge from the raw data. As we progress to knowledge, we're looking at understanding patterns and relationships in this information. Tech trends might realize that certain products are more popular among specific age groups. They could recognize patterns in user behavior, like peak shopping times. They might identify correlations between their marketing campaigns and spikes in sales. This is where the data starts becoming truly valuable, as it provides insights into the business and its customers. Finally, at the wisdom level, tech trends can use this knowledge to make informed decisions. They could adjust their inventory based on predicted demand, potentially reducing overstock of slow-moving items and ensuring popular items are always available. They might personalize their marketing strategies for different customer segments, improving the effectiveness of their campaigns. The website design could be optimized based on user behavior data, improving the overall experience and potentially increasing conversions. Sales and promotions could be timed to coincide with periods of peak user activity. By moving through each level of the DIKW pyramid, tech trends has transformed raw, meaningless numbers into strategic business decisions. This process demonstrates the real power of data in digital business. It's not just about collecting information, but about using it wisely to drive improvements and growth. This scenario illustrates why understanding these concepts is so important. As professionals in this field, you'll be instrumental in creating systems that not only collect data, but help transform it into the kind of actionable wisdom that drives business success. In this video, we've explored the fundamental concepts of data, information, and knowledge, and how they relate to each other in the DIKW pyramid. We've seen how raw data can be transformed into meaningful information, how that information becomes knowledge, and how knowledge can be applied to make wise decisions. We've also looked at a practical scenario with tech trends, demonstrating how these concepts apply in a real-world digital business context. This example showed us the journey from raw sales and user data all the way to strategic business decisions. In our next video, we'll be looking at how businesses actually use data, information, and knowledge in their day-to-day operations.